Good evening, my dear friends and students. Today I am going to bring about another physics experiment, that is the plotting of the magnetic field lines of a bar magnet. And the things that will be required for the experiment are a bar magnet, a magnetic compass needle, and a pencil that will be required in the examination, but I am taking a pen for this video. Okay, so these are the things that will be required. And the thing that we have to do at the first is that we have to align our the plane of the paper on which we'll plot the magnetic field lines. We have to align the outline of the bar magnet along with the magnetic meridian at this place. Okay, so let's see how to go about that process. So at first we need to put the bar magnet on the plane of the paper and then draw its outline with a pen. I've already drawn it, so you can see there the outline of the bar magnet. Now we need to keep the bar magnet at a far away location and then put the magnetic needle over here, over the outline of the bar magnet. As you can see, the needle is not pointing along the direction of the line which is drawn in the outline. It is pointing towards the north of Earth, or so-called north, geographic north. But actually it is pointing towards the magnetic south of Earth. There is a difference between the magnetic south and geographic north of Earth, but it is slight, and that is covered in the topic declination, but now we will ignore that. We'll usually call it in layman terms that the magnetic needle points towards the geographic north. So the topic is magnetic needle's compass pointing towards geographic north. The north pole of the compass needle pointing towards geographic north. That is the condition of this experiment. And we need to plot the magnetic field lines under that condition. So now what we will do, we will rotate the plane of the paper. That is, we'll rotate the wooden board such that the needle's direction and the outline matches and becomes parallel. See, now the outline and the magnetic needle are pointing along the same direction. That is, this outline is now pointing towards the geographic north. Okay, I'll bring the camera towards a position such that it easily covers the outline. Okay, now we can see clearly that the outline and the needle's north are pointing towards the same direction. Now we need to bring the bar magnet, and we need to check its north pole. Sometimes it gets reversed. Usually the N is written. We bring the needle towards the north pole. Now you see the reversed arrow of the needle is touching the north pole. That means it is the correct north pole. Okay. Now we place the north pole over the outline that we already drew. The outline was pointing towards the geographic north. So now the magnet also points towards the geographic north. The thing that is left to do, now the alignment is done actually, and the thing that is left to do is the plotting of the lines. Okay. Now that the alignment is done and we have placed the bar magnet oriented in the magnetic meridian pointing towards the geographic north, we need to bring the compass needle near the north of the bar magnet. As soon as we place the magnetic needle near the north pole of the bar magnet, we see that it points towards some other direction away from the north pole. What we need to do is that we need to put a point over here on the arrow mark, on the forward arrow mark. At the tip of the arrow we need to draw a point, and we need to draw a point over here also near the north pole. Then we need to move the magnetic compass needle and place the reversed arrow over the forward written mark. This mark, we need to place the reversed arrow of the needle near that mark, and we need to look where it is pointing, and then we need to another dot over the arrow mark. Then we need to repeat this. We need to put the reversed arrow again on the dot and then see where it is pointing. It is pointing this way. So we need to the dot here. Then we need to again repeat this, like that. If we do, we'll get a continuous line. See, now the arrow is changing its direction. That means it is getting curve. So I have drawn a few points on one of the magnetic field lines. Now, after you draw the points, you need to draw a freehand curve over these points. From the North Pole, the curve starts and then it goes towards the South Pole. The lines exist within the magnet as well. Remember, lines go inside the magnet as well, but we cannot draw them over here because the magnet is placed in the outline. And we need to give the arrow mark from the north because the lines start from the north, or they emanate from the north and they go into the South Pole. But they are not originating from the North Pole and terminating in the South Pole. They are not originating and terminating. They are endless loops. Always remember, magnetic lines of force are closed curves and they are endless loops. They have neither start nor end. So one of the field lines is drawn. So after plotting of a few lines, this is how the diagram will look. After that, now actually we are plotting the lines which are the lines emanating from the bar magnet. These are due to the bar magnet's magnetic field, but we also know that the Earth's magnetic field is also present everywhere. In these places, the magnetic field of the bar magnet is stronger. That's why the magnetic field of the bar magnet is dominating. But if we go away from the bar magnet, the magnetic field of Earth will dominate, and in a far away region we can plot the Earth lines. Okay, so now we will see how to plot the Earth lines. Push the camera a little bit further so that we can see the region far away from the bar magnet. The bar magnet should be placed in its original position, no doubt. It should not be removed for plotting the Earth lines. We are studying the Earth lines only under the effect of the bar magnet. So in a far away region, if we place the magnetic needle, we see that the needle is pointing in some direction. See, it is pointing in this direction. We need not think too much. We just need to plot the lines using the same technique that we used. We can put the needle's north, that is the forward arrow, over one point and put the dot on the reversed arrow, or the opposite. So these are usually Earth lines at a far away distance. Like this, we can place the magnetic needle compass and draw the Earth line. You should be careful that there are no magnetic materials near the experiment board. If there are magnetic materials, the lines of force will be modified. So this is the Earth line, and it was pointing, the needle was pointing all the way in this direction. So we need to give the arrow mark this way. Always remember, while doing this experiment, that is the magnetic bar magnet pointing towards geographic north, the lines emanating from the bar magnet are going in this direction. That's why the earth's lines will go in this direction. Only then there will be a null point here. The null point will be on the perpendicular bisector of the bar magnet. So how to check the null point? After plotting of the earth lines, we need to check the null point. The null point is a point on the plane of the paper where the magnetic field of the bar magnet and the magnetic field of the earth, which are directed oppositely, cancel each other. The earth's magnetic field and the bar magnet's magnetic field will be equal at some point over here in the perpendicular bisector. And there you can find the null point. To find it, you have to place the bar magnet near the perpendicular bisector position and then slowly move it up. In one position, you will observe that the needle becomes loose. Actually, when you bring it near the bar magnet, the needle gets rigidly pointing in one direction. It rigidly points in one direction. Then at the null point, since there is no magnetic field at the null point, the needle can point anywhere. So you need to rotate. You need to rotate the magnetic needle compass frame. And you see the needle is also rotating along with it. The needle usually does not rotate when it is in a magnetic field. It points towards the magnetic field always. But in the null point, since there is no magnetic field, the needle will rotate if you rotate the frame of the magnetic needle. See, it's rotating here. I'm rotating the frame and the needle is getting rotated along with the frame. It is not rigidly fixed in one direction. So this is the null point. So to find the null point, you need to place the magnetic needle and see where it gets rotated along with the frame. So now I will encircle this frame and I will tell this is the null point or the neutral point where there is no magnetic field. Okay, so this experiment is called a bar magnet pointing towards the geographic north of the earth, and we are plotting the magnetic field lines of the bar magnet. The shape of the magnetic field lines are seen in this experiment. Okay, hope you have understood the experiment. Thank you and good night.